Hey guys, it's Layla. Today we'll do rate equations and a bit about photometric analysis. I combined these two topics in this video just to finish inorganic chemistry. They're not really related, so sorry for that. Starting with the homework from the last video, you had to draw an endothermic graph for this reaction of calcium carbonate breaking down into calcium oxide and carbon dioxide. Now we know endothermic means a gain in energy, so we go up the graph and reactants on the bottom, products on the top. The graph is of energy over time. Okay, today's lesson, we will start with rate equations. The rate formula is rate is equal to K, which is the rate constant, and times the reactants. Now, for example, we have a reaction. A plus B gives us C and D. Now, when we talk about rate equations, we're only really interested in the reactants. So if I tell you, give me the rate equation for this reaction, you have to give me rate is equal to K times A times B. You can also be asked to give individual rate equations for individual reactants. So if I had to give it just for A, it would be rate is equal to K times A. Rate is equal to K times B. Now, if we had a number, like if we had 2 before A or 3 before B, it goes as a superscript. So A to the power 2, B to the power 3. Now moving on to the order of reaction or the order of reactants. Now we have 4 different kinds of orders that we can use. In chemistry, we use 0, first, second, and third. They're very common, and third is not as common. So when you have a number, the superscript above the reactant, that is the order of that reactant. For example, small a for A, capital A, B for capital B, and the total order of the reaction is going to be A plus B. Now let's speak about each of them individually, starting with 0 order of reaction. So when we speak about order, we're interested in what the changes in the concentration of the reactant will do to the rate of the reaction. So we have a concentration of an element, of a reactant, let's say X, and it is 0.01. And the rate is, let's say, 12 moles per dm cube per second. That is the unit for rate. So if I double the concentration, make it 0.02, if there is no effect on the rate, it continues to remain 12, then it is a 0 order reaction. If I triple the concentration, make it 0.03, and the rate is still the same, then the reaction is also 0 order reaction. When there is no change to the rate, no matter how much you change the concentration of the reactants. Now, first order reactions, they are the change made to the concentration of the reactants is directly proportional to the change in the rate. So this is important. So you will get a linear graph here. So if I have 0.01 concentration again, and I have 12 as rate, and if I double the concentration, my rate is going to get doubled. If I triple the concentration, my rate is going to get triple. So there is a it's directly proportional. So this is first order reaction. I will do second order and third order together. So second order is when you change the concentration, you double it, and the rate changes to the power of 2. And third order reaction is when you double the concentration of the reactant, but the change in the rate is to the power of 3. So this is what second order and third order reactions mean. For example, again, we have a concentration of 0.01, and our rate now we'll say is 3 mole per dm cube per second. So if I double the concentration, 0.02, my rate is going to be 9. Why? Because 3 to the power 2 is 9. If 3 went to 6, it would be first order reaction. For third order, if we double the concentration of the reactant, the rate will increase to the power of 3, so it will be 27, and that will be third order. These values are found experimentally. You cannot just guess them or get them from reaction. Okay, so if you're asked to write the rate equation for the reaction, you just put the letters A and B. That was it for rate equations. Now we'll move on to photometric analysis. Now, photo from the word, it means light. Metric is like measuring light. So photometric analysis is like trying to find the concentration of a sample. So a sample solution that you do not know the concentration of receives radiation in the form of UV light, okay, and it absorbs this light. The solution will absorb this light, and as a result it will give us the concentration of the sample. How? Depending on how much of the light has been absorbed. The procedure that we use to find out the concentration using light is known as absorption spectrophotometry. Okay, there is one formula that you need to know. It is known as Beer's law, and it tells us the absorbance of the solution. So its absorbance, denoted as A, is equal to logarithm of intensity. Standard intensity over the actual intensity is equal to epsilon and lambda. Now epsilon is molar absorptivity, lambda is the wavelength, times the concentration, times the length. Under standard conditions, the absorbance is directly proportional to the concentration. Why so? Because in under standard conditions, the concentration is 1 mole per dm cube, and the length is also 1 centimeter. So that leaves us with epsilon and lambda. Now, absorbance is equal to epsilon lambda is how much is absorbed by the compound, which is directly proportional to the concentration. Keeping this in mind, you can draw a graph of but epsilon max, which is also known as lambda max. So at this particular wavelength, the absorption is maximum. So if you're asked to draw or show this on a graph, this is how you would show it. Now moving on to the homework for today. The first one is you have to draw me a graph that represents absorbance being directly proportional to the concentration of the analyte. Now this is known as the Beer's law plot. I haven't shown you how to do it, but I feel like you should be able to do it. I will give you a little hint, and that is going to be linear. Okay, the second question is I will give you a reaction and you have to give me the rate equation for this reaction. And the last question is I will give you experimental lab values and you have to give me the order of the reactant. Look at all three of them carefully, see the changes and state which order ClO and hydroxide ions are in this particular lab experiment. And that would be it for today. I will see you in the next video. I might test you on inorganic chemistry and then move on to organic chemistry. All right, take care. Bye.